All right, so we're back to take a look at some more coordinate geometry. And the second part of this section focuses on determining whether a parallelogram is a rectangle, rhombus, or square, or which of those it is if it's more than one. All right, now our textbook focuses on a method that really focuses on the diagonals and a lot of characteristics of the diagonals. All right, so in their workout example that they gave you, you're going to notice that the first thing they did is they found the length of AC and the length of BD. All right, and notice that both of those are 8. All right, so when I look at this, all right, AC and BD are the two diagonals. All right, they already told me I was a parallelogram, so I have a parallelogram with congruent diagonals. That's enough to give me rectangle. All right, so I'm at rectangle just out of that piece. All right, now the next thing that they did is they went to the slopes. All right, because we know if the slopes of the diagonals are perpendicular, all right, so if they're opposite reciprocals, so those two lines are perpendicular, all right, then we're going to have a rhombus. All right, so what they found is they found that one of the slopes was 0 over 8, and they miswrote there, that should equal 0. All right, and the other one was 8 over 0. Now, those are opposites and they're reciprocals. All right, one's a vertical line, one's a horizontal line, if I was to draw those in on the picture. So we end up with, all right, opposite reciprocals or perpendicular lines. All right, so this section gives us rhombus. Now, from class today, we know if something's a rhombus and a rectangle, all right, then it has to be a square. There's really no other option. All right, so that option, honestly, their method works great. I tend to find, though, I like to start with slope and work from slope, and then at the very tail end do one set of distance formulas to get us through. This is going to give you kind of almost a uniform way no matter what question they ask. You're going to be able to work your way through. So we're going to pick one of these. We'll go ahead and pick 3. And on 3, first thing we're going to do is we're going to draw a picture. All right, so we're going to get these points plotted. We've got -2, -1. That's A. We've got 0, 2. All right, that's our B. We've got 2, -1. That's our C. And then we've got 0, -4. Which is down here, and that's D. Okay. And again, I'm drawing this so I know what opposite sides are. All right, so for me, the first thing, just like the last problem, I'm going to start and find all the slopes. So slope of AB is going to be 2 minus -1 over 0 minus -2, which is going to be 3 over 2, or 3/2. All right, now I'm going to go slope of CD, because I want that opposite side. All right, so when I go to CD, I've got -4 minus -1, all right, over, and then I've got 0 minus 2. All right, so if I push that together, that's going to be a -3 over a -2, or 3 over 2. All right, so right there, that's enough to give me that AB and CD are parallel. So now I'm going to do the same thing, but on AD. So slope of AD. AD, I'm going to have -4 minus -1 over 0 minus -2, which is going to give us -3 over 2. All right, so I've got -3 over 2. And then I'm going to go to, let's see, that was AD, so BC. So on BC, I get -1 minus 2 over 2 minus 0, which is a -3/2. All right, so now notice both of those had the same slope, so I definitely have a parallelogram. All right, definitely have a parallelogram at this point. Now I'm going to look at the slopes and see if they're opposite reciprocals. All right, so the slope of AB is 3/2. The slope of the consecutive side AD is -3/2. All right, these are not opposite reciprocals. So the lines are not perpendicular. All right, so it's not a rectangle. All right, if the slopes would have been 3/2 and -2/3, then we'd be looking at a rectangle for this. All right, so the last thing I'm going to do is I'm just going to check two consecutive sides. All right, and I'm going to do that with a distance formula. So we're going to do AB and BC. All right, so distance AB and distance BC. So distance for AB, we're looking at square root, and then we have the change in x's, so -2 minus 0 squared, plus the change in y's, so -1 minus 2 squared. All right, that's going to be square root of a 4 plus a 9, or root 13. All right, for BC, right, BC, I've got square root of change in x's, which would be 2 minus 0, plus change in y, which is going to be -1 minus 2 squared. All right, that's going to be a 4 plus 9 in there, or root 13. All right, now I've got a pair of consecutive sides that are parallel and congruent. All right, whoops, sorry about that. All right, and if I have a pair of opposite sides that are both parallel and congruent, because again, we just got that AB is root 13, all right, and we got that BC is root 13. All right, so we have two consecutive sides in a parallelogram that are congruent. Excuse me. All right, and when I have consecutive sides, excuse me, when I have consecutive sides in a parallelogram that are congruent, that tells me that we push into the category of rhombus. All right, so when I look at this, we were not a rectangle, all right, but we are a rhombus. All right, now it can't be a square because to be a square, it has to be both a rectangle and a rhombus. All right, to me, this strategy is going to be your best route to go on each of these because it hits all of them right out of the gates. All right, up here, the slopes will tell you whether or not it's a rectangle. It'll also confirm that it's a parallelogram if that hasn't already been done in the wording. All right, then the consecutive side distances, if you know it's a parallelogram, if two consecutive sides are congruent, that forces you to have a rhombus. If that's not true, it won't be a rhombus. All right, so that's how I'd approach each of these problems. So those are my examples for each of these, and then you always have the book example to take a look at for an alternate method. This is what you're going to be working on tonight's homework. So if I jump real quick to tonight's homework, all I want you to do is work up here through 11, so you've got 11 questions. All right, the first few are going to be very straightforward, just property questions. All right, so put the information you know on the picture and then do your best to work through them. Now, when we get down here to the bottom, all right, those are the three that are really the ones that we're focusing on today. So 9, 10, and 11, I would say, are the most important problems tonight. I'd scoot off to the side, I'd draw a nice big picture for yourself, and really focus on that method that we worked through on that last one, all right, where we're going slopes of all the sides to show opposite sides are parallel. All right, check and see if consecutive sides are perpendicular. All right, if they are, you're in the category of rectangle. All right, but then no matter what, we keep going. So from there, then we check one pair of consecutive sides. All right, if the consecutive sides are congruent, then we can say that it's a rhombus. And if it was both a rectangle and a rhombus, we could say it was a square. All right, so in this one, all we can really say is a rhombus. But again, the strategy is still there. All right, so that should take you through tonight's homework. You should be in good shape, and I will see you guys tomorrow.